Alright, this is example 1 from your notes. We are going to be graphing this beautiful looking function. My mom always used to say that every function is beautiful inside. So your notes goes through 4 steps to do when you're trying to graph these things. If you can, simplify. So I'm looking at this thing. Doesn't seem to be much I can do. I can pull out a 4 on the top. I'm gonna get this. I can pull out a 4 in the bottom as well. Gonna get that. The 4's will cancel. 4 divided by 4 is 1 after all. And you're gonna be left with 3x over x minus 2. Great. So at this point, it's kind of personal preference. I like to find my asymptotes first. So I'm gonna go ahead and find my horizontal asymptote. Okay, so this is thinking back to the notes from yesterday. So you have this function, and I think I'm going to use this marvelous puke green color here. So looking at the degree of the 2 leading terms here, they're both 1, so they're the same. So when that happens, you're going to get the horizontal asymptote being equal to the degree, sorry, not the degree, but the leading coefficient of the top of the numerator. So that's a 3. And it's going to be divided by the coefficient of the highest degree in the bottom. So that's 1x. So you're going to get y equal 3. Now let's go ahead and plot that using this beautiful puke green color. Reminds me of my kid's, well, his poop actually, but that's supposed to be y equal 3. So make sure you're labeling these things. I am going to briefly try to use the eraser here. One moment. Oops. There. Okay, so that is the line y equal 3. That's not any better. There. I'm going to try one more time. You know, maybe I'll edit this out. Maybe I'll keep it in for your entertainment. Okay. Mama used to say 3rd time is the charm. There. Perfect. Okay. So, horizontal asymptote, done. Let's do the vertical asymptote. So this is just where you're taking the denominator and you are setting it equal to 0. So you're getting the point x equal 2. Let's go ahead and draw that. I lost my puke green color. I can get a similar color to it, but not quite the same. So there's my vertical asymptote x equal 2. Alright, you're in a good spot now, because you still haven't found the x and y intercepts. And when you do, you're going to get a couple points on the graph that might help you graph it. So let's go ahead and do that. So let's go ahead and find, say, the x-intercept. If it exists, it might not. So that means y is equal to 0. So I'm going to go take my function. I'm going to set it equal to 0. And this will be probably the last time you're going to see me do this step. So no matter what, to solve this thing, you're going to have to multiply both sides by x minus 2, by whatever's in the denominator. So when I do that, I can put it over 1. X minus 2 divided by x minus 2 is just 1. On the other side, though, you have a 0. So when you multiply anything by 0, you're still going to get 0. So each and every time you do this, you're always going to just have the numerator. Okay, so when you're solving for the x-intercept, you're setting y to 0. You can always just jump to this step here. So just set it equal to the numerator. It'll save you a bunch of time. So I get x equals 0. I'm going to write that as a coordinate. So that's the coordinate 0, 0. And I'm going to plot it right away. So that means I have a point right there. Beautiful. Let's do our y-intercept. So that means that x equals 0. So I'm going to go back to my function. Going to plug in 0, and it doesn't hurt to be careful, so show a bit of work. So in the top I'm going to get 0, in the bottom I get -2, so I end up just getting the point 0. So again, as a coordinate, that is 0 for x and 0 for y. We already have that point. Ah, shucks. So to get some more points, or to figure out the shape of the graph, probably want to use some smart points. Sometimes this is unavoidable, so making a little table of values can help. Keep in mind that in general, the graph is going to want to hug the asymptotes. So we're going to go ahead and do the table of values anyways, but in time you might feel more comfortable, say, sketching out what's going to happen without the table of values. There will be times where you need the table of values either way. So I'm going to figure out what's going to happen down here on the bottom left part of the graph. So it's really up to me. I'm going to pick maybe x equal 1. And I'm going to be plugging into my function. So in the numerator I'm going to get 3 times 1, so 3, and in the denominator I'm going to have 1 minus 2, so I'm going to get -1. So that's the point, -3 for y. I'm going to go ahead and plot that. Maybe we'll even make this kind of accurate. There. So I can already see the graph is wanting to go down and eventually snug up to that vertical asymptote. Same thing's going to happen as I move to the left. So I can save myself some time because this is just a sketch, and draw it like that. If you're not sure, feel free to pick x equal -1 and figure out what you get. Alright, let's figure out what happens to the right of the vertical asymptote. So my vertical asymptote is x equal 2. I'm going to pick maybe 3 and see what happens. Plugging it into my function, I am going to get 3 times 3, so 9, and then 3 minus 2, which is 1, so I get 9. Alright, so this I can't really sketch, so I'm going to label this point 3, 9, and again I know it's going to snug up to that horizontal asymptote, and then it's going to want to snug up to the vertical asymptote. So there's the graph. Looks like one of the ones we did in grade 11. The exception is that now the the horizontal asymptote is no longer y equals 0 all the time. Great. Alright, example 2 from your notes. Let's do some more. Why not? Okay, so I'm looking at this one. Looks like I can do a couple things. Before I get started, I can factor the top, and I can also do something to the bottom here to make it look a little bit more familiar. So whenever you see the order exchanged, usually that means that you can pull out a negative. So in the denominator, if you pull out a negative, then all your signs are going to flip. So you are going to get, instead of this negative x here, you're going to get positive x, and then instead of this positive 4, you're going to get -4. When you bring the negative back in, you should get back to where you started. So that's a good first step. In the numerator, I can factor this, and this is just a regular factoring. So you're going to get x minus 4, and you're going to get x plus 3. Okay, so before I do anything else, I'm just going to note that it looks like I'm going to get a hole. Okay, that is because I have the same binomial, x minus 4, in the bottom, and I also have it in the top. So these will cancel. When they cancel, you're going to get a simplified equation of y equals x plus 3. Now, don't lose the negative in the denominator. It's still there. So it's x plus 3 divided by -1. So feel free to bring the negative into the top. So divide each term by -1. And you now have your new simplified equation. So this one's going to be pretty easy to draw. As long as you catch the hole, it's all going to be fine. So let's go ahead and find our x and y intercepts. Because there's a hole, we're not going to have any vertical asymptotes because they canceled. Okay, but we will have a non-permissible value at the spot x minus 4 equals 0, which is the binomial that canceled. So at x equal 4, that is where the hole is going to be. So we're going to want to find out the y value of that. So we're going to go to our equation, negative x minus 3. We're going to plug in 4. I'm missing my equal sign. And we're going to get y equals negative 7. So as a coordinate, this hole is at the point 4, negative 7. Other than that, we should be good to go. I did say we would find our x-intercept. So this is pretty standard fare for these questions. Going to find the x-intercept, so set y equal to 0. Just be careful with the signs. That is a negative in front there. I'm going to try to erase. Uh-oh. Okay, never mind. I'm just going to write it again. Here we go. I hope to get a more sensitive tablet here in the future once these videos have gone viral. There we go. So that's my x-intercept. I'm going to go ahead and plot it on here right now. I'm going to regret making those grid lines in a second. Okay, let's find our our y-intercept. So that means that x is equal to 0. So here we go. Plugging it in. So you're just going to get negative 0 minus 3. So you're going to get y equal negative 3, which I am just going to sketch on here. So there it is. I can now draw my line. I know the hole, coordinate of the hole over here. I have my intercepts marked. I'm going to do my best. I am just doing a sketch. So I'm just going to go out. I'm going to draw an open circle. I'm going to label that point 4, negative 7. And then I'm going to continue my line. Done. Alright, this is example 3 from your notes, coming from the beautiful Brandon, Manitoba, where it's too cold outside and there's nothing better to do at night except for math. Right off the hop, I'm looking at this one and I can see that the degree of the top and the degree of the denominator are identical. So that's telling me something about my horizontal asymptote. It is always good to be careful to make sure that maybe you don't have something canceling and you have a hole. So before I go find it, I highly doubt anything's going to cancel, but I'm going to go factor my denominator. So it looks like I'm going to have x plus 4 and x minus 2. Okay, so nothing cancels. So as I was saying before, your horizontal asymptote is going to be y equals, now in this case where the degrees are the same in the numerator and denominator, it's the leading coefficient on the top, which is 1, divided by the leading coefficient on the bottom, which is also 1. So we get a horizontal asymptote of y equal 1. That's easy. Let's find our vertical asymptotes. So that's just taking our denominator, setting it equal to 0 and solving. So you must have this step here on your exam, just so we know that you really know what you're doing. So set it equal to 0, make sure you show that, and you can solve and get x equal negative 4 and x equal 2. Let's go ahead and graph all those asymptotes. So x equal negative 4, I'm just going to draw another one of my beautiful sketches. So there's x equal negative 4. X equal 2, we'll put it over here. Notice how I'm drawing the arrows. and we had y equal 1. Of course, you would have your nice ruler. You would not be using a crappy pen like I am right now. Okay. Once you have that, we can see the general shape of the graph. This is going to be a lot like the ones in grade 11. If you have two vertical asymptotes, you're expecting 3 pieces to the graph. Because we have a horizontal asymptote, we're probably going to get some sort of parabola in the middle, but we'll have to see. So, to help us do that, let's go ahead and find our x-intercepts. So that means y is equal to 0. My equal signs are not coming out. Okay, so when you set y equal to 0, take the shortcut. When you set this equation equal to 0, you're going to lose the denominator every time as you start to solve. So you can start taking the shortcut of just realizing, hey, it's only going to equal the numerator. In this case, the only thing that's going to happen is we're going to get x equals 0. So I like to write it as a coordinate. So it's 0, 0. Let's go and find the y-intercept. That means that x is equal to 0. A little bit easier here. I'm going to get 0 in the top, and then in the bottom it doesn't really matter, but it looks like I'm going to get 4 times negative 2, so negative 8. So again, I get y equals 0. So as a coordinate, 0, 0. So I just found out that my x and y intercept both happen at the same spot, which is the origin, 0, 0. So I'm going to graph that right there. Okay, so that leaves us with a little bit of work. So when you're in one of these situations, you're going to need to pick some smart points. Alright. You know that in general, these whatever shape the graph is going to take, it's going to hug the asymptotes. So you sort of want to pick a point, say, to the left of this vertical asymptote, x equal negative 4. So I'm going to pick maybe negative 5. Going to plug it into my equation. Going to show a little bit of work. So in the top I got x squared, so I'm going to get 25. In the bottom, I'm going to have, and I'm using the factored form because it's a little bit easier to do the math. In one bracket I'm going to get negative 5 plus 4. I'm going to get negative 1. In the other bracket, I'm going to get negative 7. So when I multiply them together, I get positive 7. This is approximately 3 point something. Okay, the only reason I care about that is so I know, is it above this horizontal asymptote or is it below? So because it's a positive y value, it's bigger than 1, I know that it's going to land somewhere here. Okay, label that point, because this is a sketch. So negative 5, 25 over 7. Okay, and now you know that this thing is going to hug the asymptotes. Okay, so if you want, you can get more points. After a while, you're going to realize, hey, it's those same L shapes that we got from grade 11. So I'm just going to use a different color here. There's a wonderful color. Yeah, let's go with that. So this is just going to come down and hug that asymptote, and then it's going to hug that vertical asymptote. Okay, I'm going to leave the middle for now, and I'm going to figure out what's going on the right hand side of the graph. So that is my vertical asymptote x equal 2. I'm going to pick something a little bit bigger. I'm going to pick 3. Plug it into my equation. I'm going to get 9, and then in the bottom I'm going to get 7 times 1. So I get 9 over 7. Okay, once again, that is bigger than 1, so it means I'm above my horizontal asymptote. So put a point there, label it 3, 9 over 7. Okay, and then you know that this graph is going to come down, hug that horizontal asymptote. It's going to go up, hug that vertical asymptote. Now to figure out what's happening in the middle. So a little bit of experience. Because I already have this point, and I know this thing's going to hug the asymptotes, the vertical ones, it's not going to cross the horizontal one. I know it's going to be some sort of parabola shape that's pointing down. Something that is going to look like this. Now, if I wasn't sure, there's no problem. I can pick some x values. So maybe I might choose, I don't know, I might pick something easy like x equal 1. So just to check, I pick x equal 1, I plug it into my equation, and in the bottom I'm going to get 5 times negative 1, so I get negative 5. Okay, just to confirm, so it's a negative y value, so when x is 1, say around here, then it's already starting to curve down towards this vertical asymptote. I don't need anything else. I know that it's going to be similar on the other side. So this one is all done. There's your graph. Looks very similar to the ones we did in grade 11. Okay, this is example 4 on page 5 in your book. This is one of the dreaded questions where we're going to get a slant asymptote. You can tell because the numerator, the degree of the numerator is 2, the degree of the denominator is 1, and therefore you're going to get a slant asymptote. To find out what the equation of that asymptote is, you are going to have to use synthetic division. Okay, so look at your denominator, compare it to x minus a. If it's going to be x plus 2, then a has to be negative 2. Grab your coefficients and let the fun begin. Bring this down. Negative 2 times 2 gives you negative 4. Alright, our original polynomial had an x squared, so we're going to get a 2x plus 1. This negative 14 is the remainder, so plus negative 14 over x plus 2. Now, this part here, you need to consider what happens as x goes to infinity. Pretty easy, really. You're going to have negative 14 divided by a really big number, infinity plus 2. So this essentially is going to go to 0. What's left over is actually the equation of that slant asymptote, which would be 2x plus 1. Done. We can go ahead and graph it. Probably want to know the x-intercept and the y-intercept of this thing. So y-intercept is easy enough. It's going to be at 1. See if I can get that there. At 1. Your x-intercept might be worth solving for. So x-intercept means y equals 0. So it looks like we're going to get negative a half, which we can just label right there. Alright, you can draw that slant asymptote. Don't forget your arrows, and don't forget to label it. Okay, let's find the vertical asymptote. So for this, you're just looking at your denominator, and you're going to get that x is negative 2. So we'll go ahead, we'll draw our nice slant asymptote, or sorry, our vertical asymptote at negative 2. At this point, it'll probably be good to factor this thing. So I'm going to take this, and I'm going to go ahead and factor. Nothing's going to change in the bottom. I do recommend that you pause at this point because you're going to have to do a decomposition on the top. But what I got was 2x minus 3 and x plus 4. Alright, this will make it easy to find our x-intercepts and our y-intercepts. So I'm going to go ahead and find the x-intercept. So that means that y is equal to 0. So plugging it in, take the shortcut. Okay, if you're setting y equal to 0, the denominator is going to disappear every time when you start solving. So you're just going to be left with the numerator, which we've already factored. So we're going to get 2 x-intercepts from this. We're going to get 3 halves, and we're going to get x equal negative 4. Let's also solve for our y-intercepts. So that means x equals 0. This is generally a little bit easier to solve for. Just be careful when you're plugging into all these brackets to make sure that you're not doing anything weird. So in the first bracket we are going to get -3. And the next bracket we're going to get 4. And the bottom bracket we're going to get 2. So it looks like we're going to get -12/2, so -6. Perfect. So that should be enough info to start drawing some points on the graph. It is just a sketch, so it ain't going to be perfect, but it is important that you label your points as much as possible. So there's my y-intercept. I'm going to go ahead and graph my x-intercept. So I got 1 at 3/2, which is about 1.5. And I got another one at -4. So I'm probably going to need to extend this graph a bit. I know it's starting to look ugly, but Mama used to say every graph is beautiful. Okay. We're actually pretty lucky on this one because we know this graph is going to come in 2 pieces, and we know that it's in general going to follow the asymptotes. So over on this side I already have 2 points. So I know that as x gets bigger, bigger, I'm going to get closer to this asymptote. So I can go ahead and sketch something like that. Excuse this not going through the point. It's late at night as I'm doing this. This is going to come down like that. Over here, again, it's going to curve towards this asymptote. And if you're ever not sure, feel free to use a table of values, grab a couple extra points, and then as we go down, it's going to eventually come down and follow this asymptote here. So that is a rough sketch of what it looks like.